some fundamental identities. So there's ones you already know about. These ones up top are called the reciprocal identities. You know that sine of t is 1 over cosecant of t, right? Or you can get it if you need to. You know that cosine of t is 1 over secant. That's cosine of t. And you know that tangent of t is 1 over cotangent, right? Then there's ones called, you don't need to know that it's called the ratio identity. You just need to know the identity. The tangent of t turns out to be sine of t over cosine of t. Is that obvious? Think about it. If on the unit circle the sine of t is equal to, say, y over 1, but the hypotenuse is equal to 1. And then you know cosine of t is equal to x, which is just opposite, x over 1, which is just adjacent, adjacent. And then what's the tangent? You know from TOA, SOHCAHTOA, it's opposite over adjacent. It's y over x. Oh, it's sine over cosine. And you could, show that from the reciprocal identity then that the tangent of t, that's sine over cosine. So cotangent has to be cosine over sine, the reciprocal of the tangent. So these are all ones that you're hopefully already very familiar with. But then there's some super duper important ones that my Calc 2 students are struggling with right now, called the Pythagorean identities, which I haven't listed here because those are the ones I want to spend just a little bit of time on. The main Pythagorean identity that you absolutely, if that's a word, I don't think it is, you absolutely have to memorize the Pythagorean identities. Here's the main one. If you memorize this one, you can come up with the other ones. Turns out that the cosine squared of t, okay, have you seen this notation? That notation means I'm going to erase this in a second, the cosine of t, the whole thing squared. Okay? When you see the cosine, then the exponent, and then the t, it means the cosine of t, the whole thing squared. Pretty standard notation. So let me erase that. So here's the main Pythagorean identity, cosine squared t plus sine squared t equals 1. It's the Pythagorean theorem, you guys. Okay. Think about it. If you look at any point on the unit circle, the unit circle has equation x squared plus y squared equals 1. Remember that? The unit circle, so if you want to plot this unit circle, you can go to an online plotter called desmos.com. You can type in x squared plus y squared equals 1. It'll plot points for you. You'll get a picture like the one in red. So that's the equation of the unit circle. And if you look at any old triangle that we've been drawing here, corresponding to any point on that unit circle, then we know that this side that we usually call x, so now I'm going back to having x stand for the adjacent side of the triangle, y stand for the opposite, so x, y. You know that x squared plus y squared equals 1. That's the Pythagorean theorem. That's where the equation of the circle comes from, by the way. But you also know that x is equal to cosine from the definitions we came up with earlier. Cosine of t, right? Where this, you can think of this arc length as t, so it's a real number, or you can think of it as the angle t. It's interchangeable. But you know that x is equal to the cosine of t. By definition, right? X over 1, but x over the hypotenuse, but the hypotenuse is 1 here. You know that y is equal to what? Sine of t. This is a huge idea, you guys. This point, any point on the unit circle, can be represented as with the coordinates cosine t, sine of t. X equals cosine of t, y equals sine of t, in other words. What happens when you plug those values into this formula for the unit circle? You get the Pythagorean identity. That's where it comes from. In other words, the Pythagorean identity, the main one, this one, it's the Pythagorean theorem. Once again. Now there's two others you can get from this first one. Let me just write them down and then I'll show you where they come from. The first one, 1 plus tangent squared t is equal to secant squared. That comes up a lot as well later on in calculus. And then also 1 plus cotangent squared t equals cosecant squared t. I said cotangent here, but what did I write? I wrote cosine, muscle memory, right? So this second one, 1 plus cotangent squared t equals cosecant squared t, okay? And then I think I'm going to divide through to show you where this second formula comes from. No, the second formula overall. I think I'll divide through by cosine, actually, cosine squared. So check it out. If I divide through by cosine squared, what do I get right here? So divide both sides of the equation, distribute the division to balance things out, divide both sides by cosine squared. What's that first guy? Cosine squared over cosine squared become 1. And then this second guy, okay, the exponent splits up over division, but it also combines over division. So you can think of this second guy as sine of t over cosine of t, the whole thing squared. In other words, this part right here, the exponents are separated, right? But over division, you can recombine them. Same with multiplication, but not addition or subtraction. Oh, but what's the sine of t over cosine of t? So that'll be tangent in the next step. And then 1 over cosine squared of t, if you think of it as 1 over cosine of t, the whole thing squared. Secant squared, right? Yeah. So this guy on the right side is the same as 1 over a cosine of t, the whole thing squared. In other words, you could think of this as 1 squared over cosine squared t, combine the exponents over division and get that, and you come up with the result, 1 plus sine of t over cosine of t, oh, there's your tangent, and then you square it. 1 over cosine of t, the whole thing squared, oh, there's your secant, and then you square it. I wouldn't do it, I'd just memorize it, it's easier. But if you're against that or you forget it, that's a way to derive it. If you know the first one, you can get the second one. And then we divided by cosine squared to get this second one. How can we get the third one, do you think? Divide by sine squared, and you'll get this third one, okay? So you're going to have to memorize these trig identities. I'll see if I can make the first test just consist of these ones. Okay, but okay, let me do a little bit to relieve your stress. You already know these ones, these top ones. You probably already know these middle ones. You just need to add to your collection this Pythagorean identity, okay? And then you are eventually, at least for the second test for sure, going to have to memorize these other two. Flashcards, you guys. Have them by your bed. One side of the flashcard, put the Pythagorean identity, the one with sines and cosines, or something to indicate the main Pythagorean identity you could put on one side of the card. On the other side of the card, cosine squared t plus sine squared t equals 1. Look at them before you go to bed. You don't even have to look at them more than once or twice. Look at them. By morning, they'll be in your head better than they were the night before. Your brain works on this, converting your memories to long-term overnight while you're sleeping.